Lesson 6.2, angles in standard position and arc length. The focus of this lesson is to relate angles in standard position to the arc that subtends the angle, only known as arc length. Now, what is arc length? Now, simplistic term, arc length is part of a circle defined by 2 points. So if you have a circle, and essentially if you have a circle like here, you have the center of that circle here, and we want to set a piece of that arc of the circle here. This is referred to the arc length. So we have A and B here. Now, at the center of the circle, this angle here is called the central angle. So that's where we have a central angle, and the radius is from the center of the circle to the circumference of the circle. So here we have the circumference. So the radius is from the center of the circle to the circumference, and the angle, right, that this arc subtends here, subtends means it's part of the circumference, is called the central angle. Okay. What we'll be finding out today is how we could calculate this radius when we're given either the arc length or the central angle, or to find the arc length when we're given the central angle and the radius. Let's recall we know the circumference of a circle is 360 degrees. That's what we all know. That's in degrees. Now, the next lesson, 6.3, we will look at radians, is another way of measuring it. Instead of degrees, we can use radians. So this is what we call the central angle. Theta is the angle in between. So the arc length is part of a circle defined by 2 points. So they're part of the circle. That's the arc length. So we're trying to find the arc length. Now, there are certain things we need to know. The arc length is proportional to the radius. So it's proportional, so we look at the radius. And all arc lengths that subtends have the same central angle. So even if I were to draw another circle here, another concentric circle, and extend these radius of it, right? The angle here will be the same, even though this arc length measurement will be different, much greater obviously than the circle inside here, the angle remains the same. Now there's a relationship between the central angle, right, the arc length, the circumference, and the radius of the circle. And there's a proportionality here, and this is what we'll be using. Now, back up here. So if we have an arc length here, and we have a central angular radius, we can use a proportional. The arc length over the circumference, so we get arc length over the circumference of the circle, which is, now the circumference of a circle, just recall from grade 11, right? Circumference of a circle is 2 pi times the radius. So if we were to replace the circumference of a circle with 2 pi times the radius, we'll have the arc length over 2 pi the radius, 2 pi times radius. Central angle, which is this angle here, is proportional to 360 degrees. So we have central angle with 360. So arc length, we can transfer that, is equal to 2 pi times the radius multiplied with the central angle divided by 360. So this will be the formula for calculating the arc length of a circle. So more or less we're finding the part, right, of a circle. We're showing one part, which is really the arc length. Now the next lesson we will be looking at a different formula, which is using radians. But right now I will focus on degrees, but also we can use in terms of measurement. Yeah. Here's a proportional. So I'll move out a little bit here. So let's see. So here we have arc length is equal to 2 pi the radius, which is this equation here is simplified. Arc length. Now finding the arc length of a circle, you can put in degrees or distance. And we'll find that it's much easier, right? Most people don't work like degrees. They prefer a distance, for example. You can say the distance is 50 degrees. Doesn't make much sense to people. But if you say distance is in 2 kilometers or 3 kilometers, let me show you what I mean. If I were to, here, and I want to find this arc length here. I call this B. This is my center of the circle, right? And C, this is my arc length. And the central angle in here say this is 56 degrees. Then the arc length here in degrees, because this total circle is 360, right? Okay, so the circumference is equal to 360 degrees. You know, the circumference is 360 degrees. We know that, right? It's circular. The distance around a circle, the circumference, which is equal to 360. So if this is 56, then also this would be 56. Same thing would be happen if we were to have a distance we have here. Let's look at the one that's more, let's see if you have 90 degrees here. Now 90 degrees is 1/4 of 360. So if this is 1/4, right, of 360, it's also right, of a circle, 1/4 of a circle. So this is also 90 degrees. So the central angle so the arc length, so here, so we can see the arc length here have the same central angle. So this is 90 degrees to 6 degrees. You can go to another one here. If we were to have 180 degrees here. So now from here to here is 180 degrees. So therefore this arc length, if I were to do this arc length over here, is also 180 degrees. So that's why we consider arc length, right? The subtends have the same, so this is the arc length here. ARC. The subtends the subcentral angle. They're equal. Now, since you want to work in the distance now, that's an angle. So it's pretty straightforward. Whatever angle in the central angle here, that's your degrees, or later on looking at radians, in terms of the measurement of it, the arc length. Now, what happens when you have distance? Here we have let's do one example here. We have, this is, this would be more than 80 degrees. Let's say this is going to be, let's do a much nicer graph here. Make this 80 degrees. And let's say the radius here is 10 meters. What is the arc length here? What is this measurement here? And this is where we're going to use our formula here. Oops, let's move up a little bit higher so you can see. Okay. So we're going to use this equation here to find arc length. So we want to find, so let's call this B and C here, and this is A. So here's my question. My question is find the distance of the arc, or the measurement of the arc length of BC. Give us a little bit of curve like that. That tells me it's an arc. So find that measurement there. And this is where you can either use this proportional one, or you can go straight and go to the arc length. I'll use this one first, because we haven't used it yet. So arc length, so I'm going to write my formula right. Arc length divided by 2 pi times the radius is equal to your central angle divided by 360 degrees. Now, from our question here, we have our radius is equal to 10 meters. Our central angle is equal to 80 degrees. That's all we need for this one. So with our arc length, which you don't know, we call that, let's say, so arc length is equal to 2 times pi, the radius is 10, is equal to your central angle, which is 80, over 360. Now we do our algebra here. I'm just doing it the long way, but we'll do the next question in a shorter way. Is equal to 2 times pi times 10 multiplied by 80 degrees over 360 degrees. Now the degrees will cancel out, and our result would be, so BC, if you want to find, going to be equal to what, 20 pi times 80. Simplify that. What do we get here? 20 pi will give us 40, or 4 over 9. So the distance now, translate that into actual number. We want meters, right? So this would be meters. Oops, didn't see that here. Well, it change this to meters. Now, I don't have to leave it like that. What I could have done, let me just get my calculator all organized here. I could put 20 pi, so I can go 20 times pi times 80 divided by 360. So 13.96. So 13.96 approximately, maybe the 2 does maybe 3 here, meters. So the measurement of BC is 13.96. The radius is 10. Now, if you want to go ahead and find the radius, when it's so we go to another question here. Let's find one where we have, instead of 80 degrees, we have one where it is 110 degrees. So this is 110 degrees. Find, let's call this XC. Okay, so we want to find measurement of arc XC. We know the radius is equal to 10 meters, and our central angle is equal to 80 degrees. So I'll use this other formula here, which is arc length. So I'm going to use this one, arc length is equal to, let's go down here, 2 times pi, the radius is 10, multiply the central angle is 80 degrees all over 360. My calculator out, so 2 times pi times 10 times 80 divided by 360 gives me a measurement of 13.96. Okay. Now, did I do that correctly? No, I didn't do that. Oh, my central angle is not 80. Sorry, my central angle is 110 degrees. Oops, no wonder I get the same result. The central angle is 110 degrees. Oh, sorry about that. Let's go to it over again. Did it correctly? I pick the same answer. It can't be the same arc length when the angle is different. So 2 times pi times 10 times 110 degrees divided by 360. Now that's more like it. So the arc length measurement of XC is equal to 19.199 meters. Obviously, this is much bigger. So more or less finding the arc length of and here we have some other examples. Here, determine the arc length of a circle radius 6 centimeters obtained by each angle. We go ahead, we have our arc length here is equal to 2 pi times, in this case, the radius is 6. So we have radius is equal to 6 centimeters. So we have 6 multiplied by the central angle, which is 78, divided by 360. So the arc length is equal to, now what will that give us here? Do all my magical stuff here. That's equal to 8.17 centimeters. Okay, let's try that again. 2 times pi times 6 times 78 central angle divided by 360, 8.168. Round up to 2 decimal places. I should make that actually 168. I should make it 3 decimal places. Centimeters. Next one we'll do, the radius is equal to 6 centimeters. So we have arc length is equal to 2 times pi times 6 times central angle is 45 degrees divided by 360. So arc length going to be equal to 4.71 centimeters. Let's verify that again. That we have 2 times pi times 6 times 45 degrees. I should put my symbol in here. Divided by, oops, not clear it. Second, 2 times pi times 6 times 45 divided by 360, 4.71. 2. Now, some of these questions are from your textbook. As a fraction of beta, determine the length of the arc that subtends the central angle of a circle radius r, including and label. Now I went ahead and labeled the circle. So we have an arc length here. We need to find 90 degrees. Your radius is 6, given here. So you have an arc length. We need to find your arc length, and this is where we're going to use our formula. Arc length is equal to 2 pi radius times central angle divided by 360 degrees, which worked out to 2 times pi times 6 multiplied by 90 degrees over 360. Let's give us, let's see here, the 2 times pi times 6 times 90 divided by 360, 9.42. Now they ask us to put it in, how is that correct? Let's see, we're 2 times pi times 6 times 90 divided by 360. Okay, which is 9.42 units. 9.424 units. Sometimes you're asked to put it in, leave it in pi. So in this case, it would be or 3 pi. 3 pi is the same as 9.42. The same thing would apply to this one. I'll let you try 2b. This is from your textbook. Negative now. I'm going to try that negative one. And you notice it wouldn't make any difference. So the arc length here, we can say it is 3 pi. Oh. So for this, the last one, d. So the arc length is equal to 2 times pi. The radius is 4. Multiply the central angle here is a 160. It doesn't matter, there's no, in this case, no negative. The negative just indicated the direction of the measurement of the angle. This is going clockwise, therefore it's negative. And this is 360 degrees. So we work that out. What do we end up with? We have 2 times pi times 4 times 160 divided by 360. Gives me 11.17. 11.170 units. If we were to complete this in or, if you work this out, this will give us 32 pi over 9, or 32 pi divided by 9. Let's give you the same result. Now, there are a few more in your textbook regarding the bicycle one. A bicycle wheel has a radius of 30 centimeters. So if you do a sketch of the bicycle wheel, so it has a radius of 30 centimeters. Now we have suppose a positive angle of rotation corresponding to the wheel moving forward. Determine the distance of direction the wheel will roll when it turns through each angle. Express the angle in terms of pi. Now they want to leave us as pi as our answer. So now the angle is 30 degrees. They want to find this measurement here, the arc length. So remember our formula, what it is, right? It is 2 times pi times the radius multiplied by central angle all of that. So we have arc (360°). So the arc length here would be 2 times pi times the radius, in this case would be 30. So we have radius is equal to 30. So a central angle multiplied by 30 divided by 360°. Work all of these out. 360 is all going to be. The answer is 5 pi centimeters. So this is really 5 pi cm. Next is the same, follow through. You can try the other two. I've posted the answers on the blog. The next one here, we have, look at our formula, which is 2 times pi. Now radius, remember, it's 30. 30 times 225 divided by 360. And this worked out to be 37.5 pi centimeter. This here would be 2 times pi 30, 315, against your radius. And this is 52.5 pi. This is 2 pi 30 is the radius. Central angle is 60 divided by 360. Work it to be 10 pi centimeters. Now here it said a winch has a diameter of 10 centimeters. As the winch rotates, so the winch is rotating here, it pulls a cable. Exactly how much cable is pulled when the winch turns to each angle. So in other words, every rotation, which is a circumference, right, of this winch around here. So this roughly would be 2 times, right? So once you find the circumference, you multiply by 2, or the circumference divided by 360 times the radius. So let's look at this question here. Here we have the radius now is equal to 5 centimeters because the diameter is 10. Okay, so remember the diameter or the radius. The radius is equal to the half of the diameter. So the radius in these cases here would be 5 centimeters. Okay, radius is equal to 5 centimeters. Radius is 5 cm. So to find the arcs obtended, more or less right here, that's what you're finding here. It will be the arc length is equal to 2 times pi times the radius. Let's write this much more legibly. Okay. Our central angle now, in this case, because we are making it 720 So we have so let's see what that comes out to be. So by the way, if you didn't use the radius but use the diameter, you have to remove the 2. So let's see what we get here. 2 times pi times 5 times 720 divided by 360 give me a measurement of 62.83. That'll be centimeters. Now, if you want to work that in radians, that would be what? How much would that be in pi? 20? Would be 25. Let's see if that's correct. Yes. Or 20 pi. Okay, this would be 2 times pi times 5 times 480, all divided by 360 degrees. And that will give us a measurement of 'Okay, let's work that out here. Two times pi times 5 times 480 divided by 360 gives a measurement of 41.88 centimeters, or it worked out to be 40 over 3 pi. So if you go 40 divided by 3 multiplied by pi, give us the same result. Okay, the last two questions. For it to be pi, be 2 times pi times 5 times 432, all divided by 360, and this worked out to be 2 times pi times 5 multiplied by 432 divided by 360 equals 37.699 centimeter, or 12 pi centimeters. On the last question, maybe I should highlight these questions here, so it shows up much better. Final question in this part here, we have 2 times pi times 5 times 2000 divided by 360 degrees, and that would be 2 times pi times 5 times 2000 divided by 360 give us 174.533 centimeters. Or if you're going to write it in 500 over 9 pi. So you have the same result. Now, all along we've been finding the arc length. Now, what happens if you're asked to find the radius when you know the arc length? So I'll show you one example how to find the radius when you know the arc length. So find the radius of the circle of the central angle is 225 degrees and the arc length is 27.5 centimeters. So here is your diagram. Here is your circle. Your arc length is 27.5. Your central angle is 225 degrees. You need to find the radius. So we'll use our formula, proportional formula, to find your radius. Now here, so we need to find the radius. We know the central angle. We substitute the values that we know into our equation and solve for r. So the arc length, in this case, we know it's 27.5 divided by 2 times pi. We don't know r. So the r is the unknown factor. That's what we are going to find. So we know the arc length is centimeters here. The central angle is 225 degrees divided by 360 degrees. Now, you can do your mini algebra here, and you multiply and then divide. So now, or you can do the cross multiplication method. Either one is fine. So we'll do 2 times pi, so it becomes, multiply this 2, it becomes 27.5 multiplied by 360 degrees is equal to 2 times pi times r times 225. Now I need to get rid of this 225 and 2 pi. So now I'm going to divide by, maybe I'll do one more line. So we have 27.5 multiplied by 360 degrees is equal to 2 pi times the radius times 225. I want the r by itself, so I'm going to divide by 2 pi times 225. Goes oneself once, so I do the same thing on the left side. So r is equal to 27.5 multiplied by 360 degrees divided by 2 pi times 225 degrees. Let's just work that out in our calculator. So 27.5 times 360 divided by 2 pi times 2 times 225 gives me a measurement of 7 centimeters. So 7.00 centimeters. So the radius, show this up here. So the radius for this circle is 7 centimeters, approximately 7 centimeters. Okay. So our goal today was to relate the angle and standard position, but also to find the arc length of a circle, the arc length that subtends the angle. We learned about the arc length, central angle, radius, and circumference. We've solved problems relating to finding the arc length, and then finding the radius when the arc length is given, and the central angle. So your task as a practice question is to work at question 3 on page 486, question 3, B and C. And also question 4, if you would attempt these questions again that we just did. Just attempt some of the questions in your assignment booklet. The next lesson, we are going to look at developing a relationship between degrees and radians in measuring angles.